Hi folks, welcome back. In this session I will show you how to map the environment. So in the last session we designed an apartment environment, and today we are using SLAM algorithms, namely Gmapping, for generating an occupancy grid map of this apartment environment. So therefore we have to first add some sensor to our differential drive robot to recognize the walls, and the sensor we will add here is a leader, namely a Hukuyu leader. So let's go into the simulation environment folder, into our models folder, and into our diff drive model, and let's add our leader sensor. So therefore we start by going here into our diff drive chakra, and here we add now our Hukuyu laser. And that's it basically. We first add the link, I call it here laser link, and I use a simple as a collision, a geometry, a box, which X Hukuyu, Y Hukuyu and Z Hukuyu as the lengths of each side of the box. And I also use for the visual simply a box geometry. However, you can also use a DIA mesh to get a real looking like Hukuyu laser. For now we simplified it to simply a box geometry. Then I add some inertial just to get to not get any problems, and at the end I add a joint, so Hukuyu joint here, it's fixed, and here I define where my Hukuyu laser is attached onto my differential drive robot. I use as a parent link my base link, and as a child link my Hukuyu laser link. And that's it basically. So that's what we need to add here in our diff drive chakra for adding our leader sensor. So here in the parameter dot chakra I have to add my X, Y and Z Hukuyu values. That's simply this part. And in my diff drive gazebo, here I have to add now my leader plugin, so my Hukuyu laser plugin. Therefore I will give him here the reference, so my laser link. Then I define the sensor, so it's a ray type sensor, and it's a head Hukuyu sensor, so my simple leader sensor. I define the pose. I want to visualize my Hukuyu laser, my Hukuyu leader. If you put that on false, we don't see the rays. If I put this on true, I see kind of blue rays from my Hukuyu laser going out into the environment. It's quite nice to visualize this. If you have just limited computational power, just put this on false. I have to define the update rate, so in heart. So I use here 20 hertz. Then I use here the samples, the number of samples, so I use here 720 rays for my laser. I define the resolution, and I define the min and the max angle. And here I use simply p half, and so minus p half and plus p half for defining the minimum and the maximum angle. So I don't have a full rotation here. I have to define the range of my scan, so it's from 10 centimeters to 10 meters. And I have to define the resolution, and the resolution here is 1 centimeter. I can also define a noise, and here I define a Gaussian noise with zero mean and a standard deviation of 0.01. However, you can also add here more noise or less. And then I have to define here the plugin name and the file name. So this is where the file, this is the file name where the plugin is defined basically. And then I have to define here the topic name. So you're already familiar with topics, with ROS topics, and the scan. So the name scan is now used for our leader topic, on which then our messages will be published. and then I have to define the frame name, and the frame name is simply our laser link here. Okay, and that's it basically. So that is what we have to change on our model, on our diff drive model. So nothing else, we don't have to change nothing else. And now we can go to our commander. And here in our commander, I added a different launch file, which is called now mapping.launch. And in this mapping.launch, I just simply start my apartment.launch. And then I start the node gmapping, name slam gmapping, and the type is slam gmapping. And I output it on a screen. Then I have to define my ODOM frame. So my ODOM frame is simply my ODOM link. My base frame is my base link. And I have to define the scan name, and the scan name is simply, in my case, scan. And that's it basically. Then we can open up a new terminal. And the first step what we have to do is to install our gmapping package. And for installing our gmapping package, we can simply use this. So we use sudo apt-get install and ROS melodic. So melodic is my version here, my ROS version here, and then the package is called gmapping. I already have this installed, so I already have the newest version, but probably you have to install it, so because you don't use it before, or you didn't use it before. And what we also install right away is the teleopttwist keyboard if you didn't do that already. So that's basically this. I installed that also. Okay, so now we can simply go to our package again, so to our workspace, and we can source the environment again, and then we can simply launch our mapping launch file, and now we get our system here. So as I told you, we got now here the rays. The blue rays are our leader rays, and as you can see all the single rays here, and basically if you count them, that will be the number will be in total 720. Okay, so we can also have a look onto the generated map already. Therefore we open up another terminal, starting Arvis, and in Arvis we can simply add by topic our map topic, which is published by our gmapping node, and here we can see now our occupancy map. You can see nicely here the walls and the free space in white, and the unknown space is everything else here. And if you now drive around with your robot, for example, let's open up another terminal, and use teleoptwist keyboard for driving around with the robot a bit. So let me drive this robot around. Okay, if we then have a look onto our WIS map again, you can see the map gets filled and filled. Okay, so we can do that now for the whole map, so that we get then a complete map of the environment. And if we have done this for the complete map, we can save this map. And for saving this map, we can simply use then the following code. We can use the map server node. Therefore we first have to install this node by simply typing sudo apt-get install ROS melodic map server. Again, I already installed this version, and we can use this node now to save our map. And to doing this, we can run the map server. So this is a map server package, and we can use the map saver node. Then we use the command -f. So that means basically that we save this. And then we have to define a name. For example, I simply call it now my map name. And if I run this now, it received some map information, and writing this to our mymap name.pgm and mymap name.yaml file, and done. And we will find this in the same folder as we have been here, so in my home folder right now, and I can have a look here, my home folder, and here are my map data. And in a later video, or in the next video, will I show you how to load this map data and how to navigate based on a given map with also available nodes like MoveBase, Global Planner and Local Planner.